There are multiple factors which we have to consider in tomato greenhouse cultivation process, such as follows. 1. Seeding. The propagation area or seedling nursery area must be cleaned and disinfested prior to use. Fresh seed is also important, as seed older than 1 year can have reduced germination rate and vigor. 2. First transplanting into rock wool blocks. The young seedlings are transplanted into rock wool blocks when the cotyledons, seed leaves, begin to touch or when the first true leaves appear. The rock wool blocks are soaked completely with full strength feed solution EC 2.5 ml MCHO at approximately 23 degrees Celsius, just prior to transplanting. 3. Plant density. Determining the plant density is a very important component of the greenhouse preparation and determines the number of seedling plants required for the production greenhouse. Plant density is directly linked with final yield and quality. 4. Setting up the greenhouse to receive the plants. Once the greenhouse has been thoroughly cleaned, the next stage is to lay down the growing media in rows to receive the plants. The sawdust bags or rock wool slabs are laid down in double or single rows to meet the requirements of the planting density target. 5. Hanging trough system. The hanging trough system is a variation on the single row system. The major difference is that the growing media is placed on troughs that are approximately 4 feet of the ground. The troughs are suspended from the roof, and this places additional structural demands on the greenhouse. There is also additional expense associated with capital costs of the troughs. 6. Transplanting into the production greenhouse. The seedlings will be ready to transplant into the greenhouse at 5 to 6 weeks of age. The plants will have 7 to 8 true leaves at this point. Some growers place the plants on the plastic of the sawdust bags or rock wool slabs in the production greenhouse for the last week. The reason for this is usually a lack of space in the nursery, as the plants require increased spacing. 7. Plant balance. The goal of greenhouse tomato production is to maintain the maximum sustainable yield of high-value tomatoes for profit. Plant balance is defined as the partitioning of the resources of the plant towards vegetative growth, the production of stems and leaves, and generative growth, the production of fruit. The optimum plant balance is the balance between vegetative and generative growth required in order to attain maximum sustainable yield. 8. Pruning and plant training. Tomato plants are trained to one stem that is physically supported by twine hanging from an overhead wire. The wires are located above the rows and run the length of the greenhouse and are usually placed 1 foot beneath the gutter height. The standards for how to prune and manage the plants are set by the head grower, and the implementation of the pruning standards is accomplished by the workers according to a schedule. In larger greenhouses where there are a number of workers, efficiency of the plant pruning and handling tasks can vary by worker. Efficiency of workers improves when they are motivated. Work organization can have a significant impact on motivating workers. 9. Twinning to increase crop density. As the crop moves into the summer season, the increased light intensities and associated increase in temperature serves to put more stress on the plants. Increased stress directs the plants to become more generative. The increased generative focus results in shorter, smaller leaves and less growth to the stems. Over time, and without correction, the crop canopy becomes sparse. The fruit do not fill properly and are exposed to the direct sunlight, which results in further quality problems associated with overheating, shrink cracking, and blossom end rot. 10. Flowering. Flowering is a prerequisite to fruit development, and delays in flowering generally result in delayed fruit production. It is important for growers to understand the process of flower development and how maintaining optimum growing conditions ensures flower development for maximum sustainable yield. 11. Pollination. Pollination is the critical event where receptive flowers begin to develop fruit. The tomato flower has both male and female structures. The male structures are associated with pollen development and include the anthers, which hold the pollen. The female structures include the stigma, the structure that receives the pollen, and the ovary that eventually develops into a fruit if pollination takes place. 12. Fruit set and development. Consistent high fruit set is a prerequisite to high yield, and pollination is the prerequisite to fruit set. Pollen germination is temperature dependent and takes about 1 hour at 25 degrees Celsius. Pollen must adhere to the stigma to allow germination to take place. If the relative humidity is below 70%, or the temperature is outside the range of 17 to 24 degrees Celsius, the adherence of pollen on the style may be reduced. The rate of fruit development is dependent on temperature. Optimum day temperatures range between 18 to 20 degrees Celsius, with night temperatures dipping to 15 to 16 degrees Celsius, to meet the optimum 24-hour average temperature of 19.5 to 20 degrees Celsius. The optimum night temperature for fruit set is in the range of 15 to 16 degrees Celsius. 13. Harvest. The fruit of beefsteak tomatoes is preferably harvested at color break, where a yellow-orange coloration is evident at the blossom end of the fruit. At the very minimum, tomato fruit must be at least at the mature green stage before harvesting. Thank you for watching our video. If you liked it, please do like and share and subscribe to our channel.